Yes, good evening to you all once again. Today I am going to explain few questions which have been asked in previous GATE examinations from this signal flow graph method topic. Okay, so let us see few questions which they have asked in our previous GATE examinations. So this is lecture number 12. It is lecture number 12. So let us see question number 1. This is question number 1. So this is based on your signal flow graph topic. The question is given like this. This is your R, this is your C. Okay, this is your node 1, this is your node 2, this is your node 3, this is your node 4, this is node 5, and this is your node 6. Between node 1 to 2, the gain is given as 1. 2 to 3, it is given as G1. 3 to 4, it is given as G2. And 4 to 5, it is given as G3. And then 5 to 6, it is given as 1. And then 3 to 5, if you see third node and fifth node, in between these two, this is given as with negative feedback minus H2. And then 4 to 2 means in between these two, 4 and then 2, this is given as with negative feedback with gain H1. H1, this is your H1, let us say. This is given. So for this, you are asking that find out the ratio of C by R. The ratio of C by R. This is question asked in your GATE examination. This is asked in GATE 1995. This is for your, basically it is asked for E and I. This is asked for E and I, electronic and instrumentation branch. Electronic instrumentation branch, it was asked. This is the given problem. For this, you are asking to find out C of S by R of S. Okay, so directly I will go for solution. Let us see the solution. How to solve this question? Because here I don't want to give you the theory part, as I have already explained in detail in previous sessions. Therefore, we have to go direct by applying the formulas. Already we know that. Therefore, solution. In solution, directly I apply step number 1. Step number 1. What is step number 1? Number of forward paths. Means from R of S to C of S, in order to reach the C of S from R of S, what are the paths available? That we have to identify, and we have to write their path gains. So from R of S to C of S, it is directly, this is the straightforward path actually. This is one direct path. That direct path you can consider as P1. P1 is equal to, what is the path gain? You multiply all the gains available, 1 into G1 into G2 into G3 into 1. Nothing but G1, G2, G3, that's all. G1, G2 and then G3, that's all. That is your first forward path. Other than this, is there any other forward path? If you see this arrow mark up to this, again if you go in this way, this is coming reverse direction. Therefore, it is not the forward path. You will not consider it as forward path. Okay. Then again from here to this, again this arrow mark is coming backward. Therefore, you can not consider this also as a forward path. Therefore, you have only one forward path for this. Okay. Then step number 2. What is step number 2? Individual loops. So how many individual loops are there? Directly you can see here from node 2. From node 2, the branch is starting here and it is going forward direction and it is coming back here. Directly it is coming here. You can take it as your L1. Therefore, individual loops are identified by the letter L1. Is it not? So it is G1, G2 and then H1. Is it not? 2 to 3 to 4 and then this. This is the one loop basically. Therefore, G1 into G2 into H1, minus is there. Therefore, minus G1, G2, H1. Already I have considered that H1 minus here. Therefore, G1, G2, H1. That is one loop basically. What is the another loop? There is another loop also. What is your L2? What is your L2? Here. So from 3 to, it is G2, G3 and then it is coming reverse direction. From here, it is coming reverse direction like this. Therefore, it is G2, G3, H2 means G2, G3, H2 take minus, as you have minus there. Therefore, minus will come in L2. Is it not? Other than these two, is there any loop? For example, so there are two loops basically, and let us see, is there any other? If you start again from here forward direction, and there is no, these are two loops only, L1, L2 are available in this, that's all. That is your step number 2. Next, coming to your step number 3. What is step number 3? In step number 3, we have to identify that is there any possible combination of 2 non-touching loops and then 3 non-touching loops. For this problem is concerned, you have 2 individual loops basically. I mean, this is one loop, this is one loop, this is one loop, is it not? This is one loop, and then this is also another loop, this is also another loop, and these both these loops are touching to each other. Here at these 2 points, at these 2 nodes, these 2 loops are touching to each other. Therefore, you can write here, there are no 2 non-touching loops and 3 non-touching loops. You can write there are no, you can, okay. So in GATE examinations, you are not supposed to write, you don't have any time, and it is not at all required to mention there also. Directly it is a problem oriented. Therefore, it is academic, you have to write basically in your engineering university or examinations. But in GATE examinations, just you see, identify, apply the formula, you have to go forward, you have to go very quickly, you have to solve the question. So you can, for your so there are no two non-touching and 3 non-touching. This is not at all required to write. Just if it is nothing is there, leave it. That's all. That is step number 3. Therefore, two non-touching loops are not there. Is it not? Then coming to step number 4. Coming to step number 4. Okay. So now coming to step number 4. What is your step number 4? Formula only directly. So by using this step number 1 and step number 2, we have to find out the transfer function. The transfer function. So for finding the step number 4, this problem itself is also not required. Therefore, I will erase this problem. And your step number 4. Directly, transfer function is equal to 1 by delta sigma k. How many paths are there? You have only one path. Therefore, k is equal to 1. It is pk delta k. This is your formula. This implies your transfer function is equal to 1 by delta. If you expand this summation, then it will comes like this, p1 delta 1. Therefore, p1 delta 1 by delta. Furtherly, you can write this as, this implies, okay, so what is p1? P1, you already know that. What is p1? g1, g2, g3. g1, g2, g3. Is it not? What is delta 1 value? Delta 1 value is nothing but, so with respect to the forward path 1, is there any non-touching loop which is not touching to forward path 1? If any loop is available and which is not touching to the forward path, then you have to identify the value of delta. That we have explained in the previous session like that. But as far as this concerned, you have only 2 loops. Those 2 loops are touching to the first forward path. Therefore, obviously, your delta 1 value is what? It is 1. Therefore, P1 is equal to this and your delta 1 value is 1. Therefore, in numerator, you have this much, and by what is delta? Delta is nothing but 1 minus sum of loop gains. Sum of loop gains means how many loops you have? 1 minus L1 plus L2. That's all. Because there are no 2 non-touching loops, therefore you don't have any further parameters, further quantities. Only 1 minus L1 plus L2. Is it not? So already you know L1, L2. What are the values of L1, L2? You substitute here and finally you will get your answer. Just I will write the final step for you. So it is the transfer function is equal to, or simply C by R is equal to, what is that? G1, G2 and then G3 by 1 minus, what are the loop gains? We have seen minus G1, G2, H1 again minus G2, G3, H2. G2, G3, H2. This implies C by R is equal to G1, G2, G3 by 1 minus of minus plus. Therefore, plus G1, G2, H1 minus of minus plus again plus, what is that? G2, G3, H2. This is what the answer for that question. Means by practice you can solve this. G1, G2, G3 by 1 plus G1, G2, H1 and G2, G3, H2. That is the answer for that question. This is very, very important. Asked in your GATE examination 1995 for E and I branch. E and I branch. This is question number 1. Now let us see one more question. Let us see the second question. Let us see question number 2. Let us see question number 2. The question number 2 is given like this. So the signal flow graph is given like this. It is given like this. Actually, there is a node. This is given like this. It is given as y1. This is given as y2, and the gain is given as a, and again this gain is given as b, and here one loop is given. This is your C. Then here find out the ratio of y2 by y1. This is the question. The ratio of y2 by y1. What is that? Same, it is a signal flow graph. Okay, you are asking find out y2 by y1. How to solve? I will solve for you. How to solve this? This is asked actually GATE 1999. This question is asked in GATE 1999 for E and I. This is asked in GATE 1999 for E and I discipline, electronics and instrumentation. Okay, so what to do? Directly I go for solution and directly I will apply the steps. That's all. Not required to write any theory part, not required. So go to the forward paths. What is the first path? Your starting point here is y1 and your ending point is y2. Therefore from y1 to y2, what are the paths available? So p1, this is straightforward path. This is the straightforward path with gain a. Therefore p1 is equal to a. And then there is one more path is also there. This is the second path reaching to y2 from y1. It is going like this. Gain is b. That's all. Two paths are available. That is what your step number 1. And step number 2, as per our steps of signal flow graph method, in step number 2 you have to find out the individual loops. So what are the loops available here? Only you have one loop only. The loop gain is C only. That's all. The loop gain is C only. Okay, so if you consider these two, arrow marks going to forward direction, and it will not make any loop there. You have only one loop. That is step number 2. And step number 3. What is step number 3? What is your step number 3? 2 non-touching loops, 3 non-touching loops. You have only one loop. Therefore, there is no question of 2 non-touching, 3 non-touching. Therefore, nil. You don't have anything here, because nil means you don't have any 2 non-touching loop, 3 non-touching loop. That's all. Now, coming to your step number 4. Step number 4 is nothing but finding the transfer function with the help of step 1, step 2 and step 3. That's all. By substituting these 3 steps, the values which we have obtained, that gives your final answer. So in step number 4, that is transfer function here for this y2 by y1, is it not? This is nothing but same. What is that? 1 by delta sigma pk delta k. That's all. K is equal to 1 to 2 because you have two paths here. Therefore, y2 by y1 is equal to, so it is nothing but p1 delta 1 plus p2 delta 2, because I am expanding p1 because you substitute 1 first, p1 delta 1 plus summation means plus only na. So p2 delta 2 by, what is your delta? Delta is nothing but 1 minus sum of individual loops. You have only one loop only, that is L1. This implies, okay, what is P1? P1 is nothing but direct path A. And what is delta 1? Delta 1 is nothing but, so if for the given signal flow graph, if any loop of that signal flow graph not touching to the first forward path, is it like that? You have to identify, because for this given problem, so for the first forward path A, that independent individual loop C is touching to this path here at this node, is it not? This path is this loop is touching to both the paths. Therefore your delta 1 as well as delta 2 becomes 1, because for first forward path also that loop is touching. Therefore if it is touching, then delta 1 value becomes 1. Similarly, that's what is P1 actually? P1 is nothing but A delta 1 value is 1 plus, what is P2? B. What is delta 2? Again, for P2, is there any non-touching loop? Or if the loops, so whatever, if the available loops are touching to that forward path, then obviously the value is 1, straightforward. Okay, if the available individual loops, if the available individual loops of the given signal flow graph touches to the paths, then the value becomes 1. That's all. Means here delta 1 value is 1, delta 2 value is 1, p1 is equal to A, p2 is equal to B. That is nothing but A plus B comes in numerator by, it is 1 minus denominator. What is L1? C. 1 minus C. That's all. That is your answer. Finished. Y2 by Y1. This is what your answer. Very simple, no? This is what your answer. A plus B by 1 minus C. This is the option, one of the option given for that question. This is your question number 2. Is it not? Then let us solve one more question. Let us solve one more question. Question number 3. So, your question number is given like this. It is asked in GATE 2005. There are 5 nodes. This is question number 3. This is question number 3. There are 5 nodes you have. 2, 3, 4, 5 nodes you have. 1, 2, 3, 4, 5. And obviously this is your R of S. This is your C of S. Okay. Then between 2 to 3 you have your gain as G1, and between 3 to 4 you have your gain as G2, and then again between 3 to 2 you have your gain feedback with negative feedback, it has H1, and then this one 4 to 3 you have minus H2. That's all. This is given like this only. That's all. They have given like this. Find out C of S by R of S. Your question is find out C of S by R of S. What is the transfer function? That is your question. Asked in GATE. It is 2005 for E and I. In next presentations, I will solve the from ECE as well as EEE questions also. Don't worry. Okay, this is asked for E&I students in GATE 2005. This question is asked. You can verify. Okay. Okay. Then how to solve this? Directly apply. We know that directly I will go for step as per the steps, because we have to minimize the time, no? Therefore, what is the step number one? Number of forward path. So in which you can write P1. So what is your P1? Directly, no? Consider the direct path. So if simply arrow mark is given, take the gain as 1. Here the gain as 1. Straightforward. If nothing is given, consider the feedback, the gain of that path is 1. Therefore, here P1 is equal to 1 into G1 into G2 into 1. So, if you multiply all these, your answer is G1, G2. P1, the value of P1. Is there any other forward path is available in this? Because there is no other forward path. Only you have only one forward path only. Next, come to the step number 2. So what is step number 2? In step number 2, normally we will concentrate the individual loops. What are the individual loops here? This is one loop basically. This is one loop. Means J1 into H1 means minus J1 into H1. This is one loop. And what is another loop? There is another loop also. This one, G2 into H2. G2 into H2 minus. Minus is there, no? You have to write minus. Only two loops are there. Next, coming to step number 3. That's what is step number 3? In step number 3, normally we will focus on, is there any possible combination of 2 non-touching loops, 3 non-touching loops? Because in this problem, you have 2 independent loops. These 2 loops are touching to each other at this node. Therefore, there is no question of availability of 2 non-touching. No, there is no availability. There is no 2 non-touching. Once, if there is no 2 non-touching, there is no further question of thinking about 3 non-touching. Therefore, for this step 3, you don't have any possible combination. Therefore, leave it. Because there is no, therefore, nothing to write there. Next, coming to step number 4, if you apply this directly in your formula, step number this value and then L1, L2 values, then you will have your answer. So finally, to solve the step number 4, so we need not required this diagram. That's why I erase this and I will write that your step number 4 here. So step number 4. So what is your step number 4? Your transfer function is equal to 1 by delta sigma pk delta k. Here k is equal to how much? There are how many paths are there? You have only one path only. Only one path only. Therefore, this is equal to, what is that then? P1 delta 1 by delta. Is it not? This further is equal to, what is P1? It is G1, G2. What is delta 1? Delta 1 is nothing but, if any loop which is not touching to that first forward path, then only you will get some value of delta. That is nothing but delta 1. Otherwise, if the available loops, individual loops which are there in the given signal flow graph, if those loops are touching to that first forward path, then you will have the value of delta 1 is 1 only. Therefore, in the given problem, you have 2 loops and these 2 loops are touching to the forward path. Both the loops are touching. Therefore, your delta 1 is 1. Therefore, delta 1 value is 1. Therefore, you have G1, G2 in the numerator. That's all. Delta 1 value is 1 by, what is delta? 1 minus sum of individual loops, means L1 plus L2. Therefore, your L1, L2, this is L1 plus L2, and substitute your values of L1, L2 in this. Is it not? Therefore, what you will get? What you will get? And I will write the final answer for you. If you substitute those two, then you will get your transfer function is equal to, it is G1, G2 by 1 plus G1 H1 plus it is G2 H2. That's all. This is your final answer for that question. This is the final answer for that question. Is it not? This is the question asked in in GATE examination. It is 2005. This is the answer for that question. And see one more question. Let us see one more question. Okay. So otherwise, we will stop at this point, and we will see the remaining questions in the subsequent sessions. Okay. So definitely you can. I think you enjoyed this of solving the question solving session, you can say. And in next sessions we will see few more exam questions which are asked in previous examinations. And definitely you can also post your questions in the dialog box or in the comment box of my channel, and definitely I will provide the solution for that. And not only that, I myself uh, will try to give more number of questions normally which they have asked in many previous competitive examinations, including like GATE and UPSC, IAS examinations, and many other state and central level in technical competitive examinations, whichever the questions are asked in those examinations. Okay, so we will conclude here, and we will continue in the next subsequent sessions. So definitely, so you can share this to your friends so that they will also uh, get benefited from these sessions and finding these transfer functions of control system subject. Thank you very much.